Hey guys, welcome to our YouTube channel. Today we are going to solve our SkillTrack daily challenge using Python programming language. Before going to logic, if you didn't subscribe to our channel, then subscribe right now and make our work more meaningful. First, we'll understand our question. The program has to accept the integer r and c, the number of rows and columns, and then the matrix M1 of size R cross C, and then matrix M2 of size R cross C, and then the left edge of the submatrix is missing in M1, and the right edge of the submatrix is missing in M2. Then the program must print the submatrix as output. So now we'll take our first test case. So in this test case, we have a 5 cross 5 matrix. So this is M1 and this is M2. So you can see here the right edge is missing, and also here also the right edge is missing. So now we'll take them and put it as a separate matrix. So now we are going to check the columns, and you can see that we can take transpose for these. So it becomes like 58, 76, 86, then 73, 338, 44, and the transpose for this matrix. So and then getting after the after getting the transpose, now we are going to delete the rows which are common from the both the matrix. So you can see that the first row 66, 20, 43 is also present in that matrix, so we can delete it. Also 63, 12, 40 is present, so it will be deleted. And now these are not equal actually, so now in this, for this matrix we'll take the, you can see the right edge is missing in this matrix, so we'll take a row from the submatrix, that is, this becomes like, from this the row will be taken and it will be added here. And now we'll take the transpose of this matrix, and this will be our output. Now we'll understand the logic of this program. First we have to get the input, the integer r and c, and we have to get the input matrix M1 and the matrix M2. So now after getting these inputs, now we have to get the submatrix where the right edge of the matrix M1 and the M2 are missing. So in order to get that, we'll have the submatrix of M1 of row, for row in M1 if the length of row is less than C. So we are iterating for the row in row and we check whether the size is less than C means, then we're going to get it. So similarly, we'll have it for the submatrix of EM2, and then we have to convert it to the transpose. So we use the zip function, which will automatically convert the matrix to into a transpose. So zip asterisk will do that work. And after this, we are going to, so here it will be converted to list. And after this, we're going to remove the same rows from the submatrices. So for that, while submatrix of M1 of 0 is equal to the submatrix of M2 of 0, then so if the first rows are similar, then we are going to remove it by using the pop function. So submatrix of M1 dot pop of 0 will be removed, and submatrix of M2 dot pop of 0 will be removed. And after removing that, similarly we are going to remove from the last row, that is -1. So now after removing the rows, now we know that M2 do not have left edge, but M1 have left edge. So now we're going to get the left edge from M1 by submatrix. It will be considered as a empty list. And then, as I said, M2 do not have left edge. So, but submatrix of M1 has left edge. So for row in submatrix of M1, the submatrix of we should append the list of row with the that is in that is we'll append the list of row to the submatrix, that is to the empty list. And then, as I said, M2 do not have left edge, so finally we'll append the list of submatrix of M1, M2 of -1, M1 of -1, and to the submatrix. And we'll print the transpose of the submatrix as the output.